Should be going. I'm trying to get my stream pulled up. I got distracted for a second. Refresh. Still says stream finished. I think it's really fucking trying. For reference, I'm trying to start streaming without first creating the thing in OBS Studio. If I go, or in YouTube Studio, if I go into YouTube Studio, I can create the thing and do the thing. Great. But if I hit start streaming and manage it here, hello. Yeah, so I am live. It's just not showing up on my channel. You know, my end of my channel. It's really trying. Now I see it. Okay. So I have to do some shit to find it. Live for a whole minute took me to find it. Let's go. Copy URL. Bump. Weird. Yep. Announcements. Let me also go back over here so I can see actual chat. That would be great. Red circle. And start. Thank you. Live on YouTube, boys. Working on Laye. Okay, there we go. Stream notifications. We are now doing a thing. The thing we are doing is a thing. That, and let's let me get a copy of Chrome up. And Chrome is supposed to be my safe browser, but just in case, we're gonna... Okay, so let's come over to Laye. And we've got at least 23 issues to pick from. Lots and lots and lots of things to pick from. I might start with Knob, actually. One, this might have some things... Yep. Yellow Serade. I think we've technically done this before, but after the refactor, I've kind of regressed. For some of the things I can do with Knob. I don't have to do them right now. I don't really need a nil literal until I have nillable types. At least, I mean, I'll need it for pointers, null pointers. If ever that's probably worth doing when I start passing null to C functions. Constructor syntax is the big one. Did I support constructor syntax here and add constructor syntax here? So I think... Yeah, I think we're gonna delete this issue and move to the other one. Close this issue. It's, well, I don't want to close it as completed. I should have, I just want to delete it. It's closed, but it's not completed. So I don't want to... What do I do? Lock? I could lock it. There it is, delete issue. I just don't need the issue anymore. Okay, so constructors would be easy to parse. Oh, we'd probably want to do... Where did I put it, actually? Syntax of compound expressions. This would do it. There's no deleting issues. Just close it. Close it as not planned. Well, because it is planned. It's just in a new issue. But I did... Whatever it said was deleted. So... Add a duplicate label now. Well, for the future, I know. I'm not going to worry about it right now. So if we do compound expressions first so that I can pave the way for constructor syntax, that would be a quick and easy thing to do. So we'd have to come into test and figure out... I think the only thing using compound expressions right now is... Did I call it yield? No. I don't know what I called it. Oops, index. It might be called compound. Compound yield, yeah. So return, this should be do. That's what we're going to try to fix. Let me see if there's yield anywhere else. Oh, God. I wish I could. Is there no way to filter files to include? Yeah. In source, just in source. Uh, yeah. Let's see. No search results for yield. Okay, so then let's do test. No results found in test star.ly. Well, what about Laye? Star.ly. So that's a lie then. What is star good for? Also has a proposal for do expressions with the same syntax. Yeah, I mean, it's a pretty obvious one. That's good to know. So yield here. This is different. No yield though, because it can't be a keyword. Can't be, of course, can't be a, yep, because there's a standard library function called yield. You know, that makes sense. I was gonna say that brings up a good point. How would I call like a function called yield? Because C might have one somewhere, but that's what foreign names are for, so that's fine. I might support, by the way, like at and a keyword to turn it into an identifier at some point in the future. Let's, before I forget, actually, let's just fucking add a new issue. Consider supporting at keyword. So there are no illegal words. Yield with the and identifier value field. I can change the syntax to anything, but, oh, well. Edit. Let me do this and not. Looks better. Okay. I use this syntax because I come from C#, but I'm fine with it probably being anything. I don't like the backslash. The backslash makes sense, I guess, if you're escaping a keyword, for example. I don't like it as much for the foobar baz example, for those of you who can't see what's going on. So Raid says instead of at yield, we would do backslash yield, and then we would use the same syntax to have spaces in identifiers, where you could put it in parentheses here, and you could do fucking what was it, foobar baz to have spaces in your identifier. I don't mind it for this because it's like escaping the keyword, and Flash is your typical escape sequence character. But this, I don't know. If I were to do it with the at symbol, it doesn't look significantly better. So so like I could have a yield return, for example, while I'm here. This one is clearly do yield value. And I think those are the only two we care about. The is just unlikely case you need some reasons. I don't expect it to be used that much. I mean, I don't either. I don't expect at to be used, or whatever this ends up being, to be used much at all. It really shouldn't be encouraged by any means, but if I'm going to support it, I think I like this better. Like, just having this be the same shape as the parentheses doesn't look quite as weird. And I'm not using at for anything at the moment. Now, could you have nested? Here's the problem. Would I have to escape closing parentheses? Or support escape sequences to get a Unicode? That, I think at that point, just don't put it in your goddamn identifier. Because if it's just identifier characters plus spaces, then that's not an issue. But if it's any character, like if it's a string or something, then at that point I might just say we do at string to get, right? If I did, you could probably do like backslash string yourself, and then this would give you whatever the contents of the string are as an identifier with the exact same semantics as strings in the language. And that might be the more consistent thing to do if you want to allow arbitrary character sequences. Because then you don't have two syntaxes for strings in your language, one of which you're not supposed to use ever, right? That's my first thought. And since that's a thought, let's go and maybe do barbaz if we want arbitrary characters in identifiers. Cool. That's just my justification for that. So we have only two cases where this happens. So both of these we're going to have to check on when we're done here. So what we're going to have to do is a parser for Laye. We need to go find a compound expression here. So this is asserting that we hit this. We want to assert that we have a TK token do instead. And when we hit token do, we want to go to the next token. We then want to expect. Expect is not going to tell us if it got the thing, though. Right? So I would love to say expect. But I don't want, I think we have to like half implement expect. So speaking of, fun fact, you can usually use Unicode escape sequences anywhere, even outside of strings, at least in C++. I don't remember if you can do that in C. I think you can do something like that in C#, maybe? One of the languages I've worked with has had some kind of feature like that. I just don't remember which one it is. I know C does weird things, and I wouldn't be surprised if it was C, but I also know C# does weird things, so I wouldn't be surprised if it's C#. C# is where I get the apt syntax from, for example, so it could be that. So we want to say if the next token is not, so do I remember my own API? Laye parser at, that's what I want. If we're not at this, then we just want to, we want to return our result. I think no matter what, we do this. So if we are at it, we want to next token, just fine. If we're not at it, we're going to early out and not try to parse anything at all. Because how does the do syntax affect if statements? Do people have to write if whatever do? No. This is just for expressions, which is a good point. This should be at do or the previous one. Basically what I'm saying is that a compound expression should always be prefixed by a relevant keyword, and if there are no control flow blocks, for example, then there's no keyword to preface it, so you have to use do. That's like the high-level justification. Obviously, there's not like a keyword here prefacing this block, but so then I'm going to say all of this, and then we can say if he well, then I want a Laye token kind start token kind is kind. So then I can, after doing that, if start token kind, good catch, thank you, charade, is equal to token do, then and only then do we error out early and return our result. Bad stuff. So we eat it, else we're going to return the result combine, and they're not types, so result and a new result, a result error or failure. Parse result failure of compound expression and a diagnostic. The diagnostic would be Laye error, and that requires context, which is a Laye context to get the liar context, which is a bit unwieldy now, but that's fine. So then this would be so no, I think this is fine. If we want to do other things with the keyword do in the future, we're just going to peek ahead. So if we call parse compound expression, it's because we don't give a shit what's next. We know we want it to be a compound expression. We could have do syntax for non-compound expressions in the future, depending on how I handle monadic types, because I want to support them a little bit more in the syntax. But for now, we have, okay, so then I want p token dot location and a message. So we want to say just expected this. I believe like that. Without consuming it. So then we get here. So then I want to go to parse expression primary. Parse primary expression probably. Continue primary expression. So in here then, when we hit this, we're doing a thing. What we really want to do then is token do to parse the compound expression. Okay. So then, I mean, if I just knob test, well, there's something wrong. It's the two that we expect. So I think knob test invalid Laye token count. Okay, first of all, in Laye lib debug, or it's either debug or data. Token kind to, so it's gonna be data. Data C for Laye token kind to string. What the heck? It's not in data. Debug. Did I do it wrong? Token kind to C string. What the heck? All right. Laye.h. Token kind to C string. It's in parser. Okay. So invalid Laye token kind is 0. And it said expected an expression in Sema. What the heck? What the heck? Hold on. Does that mean we're actually getting here, though? His expression is true. Do. Okay. Well, then new question. Do token. Token do. As all of my token kinds do has to exist somewhere. Okay. So it's right there. Then if I go back to my debug, token kinds, it's right here. So it's not like missing do and going here, it's just invalid. So keywords is right here. Do goes to do. What the heck? What the heck? Unexpected token, expected an expression, 912 for compound yield. Compound yield, 912. So my first thought is it just didn't rebuild when I ran the test, but clearly it had to have. Knob test. I guess not. I guess it didn't have to have. Nod to I mean, it didn't do that. Knob isn't reporting that it's changing anything. RF out. Knob test. Did it just not rebuild and we're okay? It looks like that's all it was. Okay. So, well, we've done one feature. Before I go change knob, because clearly something's wrong. Git, we've changed 3 things. Git, change the syntax of do of compound expressions to include build systems, yes, but it's my lack of doing it correctly. Knob C, knob test, build project test runner, sure, but I also need to build project Laye driver project. And building Laye driver project. Really, I should just call knob build. But if I'm calling knob test, I want it to have its own arguments maybe. But no, maybe I don't. Right? Knob test might have its own arguments eventually. Well, okay. So if I'm passing them by value, then there's no problem there. If I just don't error on an unknown argument, because I'm going to be adding arguments back to these eventually. So I want to run knob build and allow passing build parameters. But also, I think I want to just call knob build. If not knob build, explicit would be false. Argc argv. We are implicitly building. I think the explicit flag here was so that I could do an implicit build and change the command line syntax, which is not exactly what I want to do. So maybe then, hear me out, static will ensure compilers are rebuilt. And then this does this. And then this is going to say, if not, ensure compilers are rebuilt, defer false. And then we can to-do actually pass in arguments here. So then this can just say ensure compilers are rebuilt and eventually pass in arguments, right? So then if I knob, it recompiles and then I can knob test and it does the same thing. Notably, if I rmrf out and knob test, it should now rebuild correctly and then build the test runner. Look at how quick it is to test things. From nothing, absolutely nothing, to a full, I mean, a small test suite nonetheless, but you know, running 90 odd tests from 0. Let's do that one more time in timing. It's got to be less than 10 seconds. Time I don't think is going to be reliable here because we're doing some shenanigan-y things. I'm sure it's a little bit longer than 6 seconds. It's gotta be. I wasn't counting, but not much. That's still pretty quick. We're doing good stuff. Doing good stuff. Okay, so before I forget, git sgit ac, have the test runner rebuild the compilers it's going to be testing. Easy. Awesome. Then now let's come over to, it's in here, back to issues. We have 23 open. So we just did update syntax for compound expressions. We can say, I could refer to like a commit in here if I actually remember what the fuck the commit was called. And say like implemented in, what's the syntax for looking up a commit? Reference, mention, because this mentions an issue. I want to reference not an issue, but I think you just grab the commit, right? So if I went back up here and grabbed from the most recent commits just this copy hash and said this, well, that's the big hash. Just type the hash. Yep, I'm looking for the short one. I mean, like, it doesn't really matter if it's the short or the full one, I guess, right? Yeah, that. So then we can close as completed. Cool. Boom. All right, back to issues. That gives us that. So then we could do constructor syntax. The constructor syntax parsing will be very quick and easy. Implementing Sema for it will be mostly quick and easy, and code generation will be easy but maybe not quick. I'm unsure. But I think that's one of the next ones I want, is just not having to split things across multiple lines would be fantastic. I think Sema is going to have to do a touch extra work to just handle mutability different. Like I'll have to copy the type and remove the mutability thing for assignments to non-mutable fields because the constructor is allowed to do that. I think that's all I'll have to do though. So we can do constructor syntax. I'm not opposed to doing constructor syntax. I think that would be a useful one. Function types eventually, yes. Enums would be good to do soon. Float literal so we can get more Raylib examples going would be great. Then templates are going to take a while. Operators are going to take a while. Nillable types we can parse pretty quickly, but Sema for them is going to need to like be very pervasive. So I'll have to be very in a mood to add nillable types. If people are really excited for it, maybe I do it sooner than I'm ready for. I want them before we go anywhere near like writing lots of code. I mean, I could do this as well. This would be really quick. Just to get it off. Globals wouldn't be hard, and then this comparison wouldn't be hard either. But I'll stick to just these three. So let's do, just to get my brain going again, let's try at yield syntax and consider at string. Maybe I do both right now. Give me just 2 seconds to... Everybody's texting me all of a sudden. I don't want it texted while I'm live. What does he want? Okay, let's go. Let's go. Let's go. So for at syntax, let's quickly write a test for it because it's going to be a very simple test. It's just going to generate simple, doesn't even need to be anything fancy. Let's just say escape identifiers Laye. We'll do the R directive eventually. We want int main, I think is what we're saying, is our entry point. It's been so long since I've written these. Int main, yep. Let's just return 0. And if we're doing an execution test, we want it to accept 0 as the hello, TechPath, how you doing? So let me, it was just there. Let's grab this because we'll want it. Then we could just say like tennis, the diggle. Oh my god. What are you doing here? Int yield is 10. Let's just return actually int. And if we're returning a value, it has to be yield 69. So that can be our test. That can be our test. So that's in the parser as well. We want to do somewhere down here. I keep forgetting what my functions are called. So we're in next token. We want, I think we'll do it right above string handling. So after all of our fancy operators, string right here. So case, the at symbol. We want to either flex an identifier or a string. And, or a keyword. An identifier, a keyword, or a string. That's what we're doing. But problem, I think. Maybe problem? I don't think problem. What's the signature we've got working with us? What's our contract here? We take in the parser. We define the token. We consume the next token if we've peaked. See, so we've kind of got to probably got to factor out parsing strings and identifiers. So okay, so many texts. So yeah, I think if we want to do this correctly without messing up the queuing we've got going on for peaking tokens, then we need to we need to factor out all of the stuff we're going to do here. So let's just pseudocode our way through this. We want to advance the @ symbol, and then we want to check if we're in a string. So if p, the current character, is equal to a string literal, then we're going to do this, else we're going to do this. What we're going to do here then is, we can probably then say else if is identifier character, the current character, then do a thing else we're reporting an error. The correct way to report an error here, in the tokenizer, do we do anything different? Not really, we just write the error. We just write the error. So let's Laye write error into p context, Laye context. The location would be the current character location. So lexer position, I'll have to create the location. That's what this is doing. Okay, hold on. We're going to construct the location. And we're going to say invalid character in, or beginning. We want to begin escaped identifier. Invalid character beginning escaped identifier. And then we're just going to return. The token will be empty. It'll be a token type identifier, but it'll have nothing in it. Right? So if I break here, all I have to do is, okay, at all times, token kind is token ident. Right? So we're an identifier. Even if we error, it's going to be an identifier so that we have fewer errors in the future. I think that's okay. Okay, so then if we are this, we want to Laye lex string. We could call it, and that's just going to take in p and a reference to token. It will do its best to read a string. And since it's a string, we actually have the lit rune or lit string problem, so we want to know if it's actually a character literal or a string literal. So I could just pass in the delimiting character here, right? So where do we, where do I check? That's actually a good point. How am I handling car advance? Is it just in the while and I fucking missed it? Current character is not equal to terminator. Okay. So I probably want to just pass in the terminator. But if I'm parsing a string, then I really want to know... No, that's correct, I guess. Then it's going to advance past whatever the thing is. So it's going to know. So I don't have to tell it what it is, because we're not consuming the character. That makes sense, that makes sense. I'm scrolling way too far. So I can just say lex string, and it will figure it out. It's going to know where we're at. So then the same thing can happen for Laye lex identifier, ref token, fingers token, and that really should be all I have to do to get the data. So then from here, token kind will just be token kind identifier again. So I think we do that at the end here. We just override the token kind so that we lex a string, its data is going into the token's string value, right here. We lex an identifier, its value is going into the string value. The only thing I might have to consider is disabling, oh my god, my fan is going. Disabling parsing of keywords to make things faster. So I can say false. And I think that will be nice. And then we always set it to an identifier. The string will be empty if we don't have anything here. So let's go to the top and do lex string and lex identifier, and we'll see where that puts us. So static void, because we're not returning anything. Laye lex string Laye parser p and Laye token. This will mean updating a lot of pointer access. So that's fine. And then Lex identifier. And Lex identifier, god damn it, we'll have bool allow keywords. Allow keywords. We'll do allow keywords. Okay, so that should then make both of these show up. Boom, cool. So let's go into here. All of this shit that's doing string stuff. Laye Lex string p token. Paste. So this will get de-indented twice. Everywhere that we have token dot in this function. Token dot. Token arrow. Right, and then C will just be p current character. So then assert p does not equal to null. Assert p current character is equal to either the backslash or the quote. And assert that the token is not null. So then the terminator is p current character. Boom. And now we've got string. String is easy. That should do everything exactly the same. So then identifiers. Let's see. So change into ident. That shouldn't. No, that shouldn't. That should be fine. That should be fine. That should be fine. If I say change into ident, where does that actually go? Go to identifier lex. Okay, identifier lex starts here. So I don't think this is referenced anywhere else in here. We don't come back up. So we'll just, from here, Laye Lex identifier, p token true to allow keywords. So then paste 1, 2, 3, 2, everywhere that we have token dot becomes 1, 2, 3, 4, token arrow, and then we want to only check for keywords here if we allow keywords. Nice, nice, nice. Okay, token finished. Ooh, I think that just means return in this case. Going to token finished. Didn't even consider that. Hold on. Back in the Lexer, token finished goes all the way to the bottom, which is equivalent to break. Okay, so then yeah, everywhere that we have token finished, the reason it's doing that, I think, is because we are, in this case, it's because we're in a for loop, so I can't break. In here, it doesn't really make sense, but for all of these, we replace it with return. Okay, so F32, while we're here, it might be a good time to remove the keyword float. Literal float, that's fine. But down here somewhere, I guess it's up here with the rest of the types. Down here with the rest of the types? Where did I put the types? I'm not reading quick enough. Float. I think we want to remove float, and I'll consider uint and uint sized eventually, but we definitely want to remove float. I might save that. I should save that. I should get this fixed, and we'll save it for later. But we're going to do that sometime soon. So now, if I do that, then I'm going to rmrf test out to make sure we fully rebuild tests, and then mob test. %% passed. So did this says 100% passed, which I guess is fine. But I want to probably, so we called it escaped, right? Escaped identifiers here, which, yeah, it's right there at the end. Okay, running test for escaped identifiers, it's fine. It passed. There's nothing in here to validate that the IR is correct. So I really don't even need the run directive. But everything I do has a run directive. So let's just grab one of these and see if I can remember how to write my own syntax. So I want, like, is it percent? I think I did percent, right? So percent 0 equals I32 or I64 69, and then we ret I64 0. No, I think this is going to be allocate first, right? We're going to have like allocate I64, and then I want to store into 0 I64 69, and then I want 1, come on, fingers, to load I64 0, and then return 1. I think that's what this is supposed to be. Also, let me know if I need to zoom in anymore. I don't usually program this zoomed in, so this is already kind of claustrophobic, but I can do more. If I knob test, run all my tests, it doesn't fail. It does fail. It's this one. Okay, so I can just then out Laye C S emit liar O to standard output and test Laye escaped identifiers. Zoom level is fine, IMO. Okay. How close was I? Int 64. Everywhere I have I64 should be int 64. But I think everything else is fine. Okay. Now test. Yeah, I haven't seriously worked on this in forever. Define exported main. Oh, because the one I copied from was void. Where do I put the return type? Return type. That's there. Do it again. Okay, so clearly I'm still missing something. Yep, it's not ret, it's return. Should I just compare the output? Probably, but then I gotta go find it. It's not the most readable. What now? Div. Hello, hello, how are you, Dave? 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 Let me know if I'm wrong. Exported CCC main, something like that looks fine. All right, let's go check the test output. Test output testing. Last test failed. That one, sure. Log. So escaped identifiers. Error. Line does not match expected string. 1 is load in 64 0. Comma 0. Oh, load in 64 0. I'll take that as a maybe. I asked how to pronounce it, and I got a smiley face. 100% passed. Okay, so we can call that good then, probably. So we just need to update the test then. I keep doing that. We have one more thing to do, which is this is doing the keyword, which is compiling just fine. But I should also do a string. So then I could say int fooBarBaz 35, and then return yield plus fooBarBaz. So that's going to get a touch more complicated. So we'll want 0 to be the thing we want to store into 0. Then we want 1 and to store into 1. So this is 34, 35, and this will be storing into 1. So then 2 will be load 0, 3 will be load 1, 4 will be add int 64, mod 2, mod 3, which I think is correct, and then I can return 4, and mod test. It parsed, I think, but it didn't. Okay, so I definitely did something wrong with the test output. Add in 64. Okay, so this one doesn't have the comma, which makes enough sense. Okay, we're back to 100% test pass. So as far as I care, these are correct now. We've got arbitrary identifiers in Laye. If Zedrich is around, he can update. Otherwise, that's just going to look ugly for a while. Escaped identifiers. Git s git add commit add escaped identifiers. Git push. Go to our issues. So now I need to go back up to here to grab my commit things. I'm stupid. Does it show the commit actually up here? There's the mode deletions. That's all I want, right? I can go back to my issues. So implemented in this. Well, it's just the first bit. Does it still take? It still takes. Close. Boom. Easy. Knocking things off the list. Get it out of here. Constructor syntax. Constructor syntax. Or globals. Globals are going to go all the way to the IR level, but I mean, other than Sema maybe potentially not having generated symbols, which it should actually. Right, Sema should have symbols for globals, even though they're not technically supported yet. Globals or constructors? Anybody want to do one or the other? I'm just going to talk myself out of doing both of them if I'm not careful. I'm leaning towards constructors myself, because globals aren't that immediately pressing. But I'd be fine to go figure out how close they are to being done. Like I said, I have no idea how close they are. So we fix this. That should be constructor sound. They do sound much more useful. Yes. So I'm leaning constructors. So I think supporting constructors immediately after doing that, I'm going to want to add support for. Do I have an issue in here for it? I should. Namespace types. If we do constructors, which I think we will, I'm going to go also do namespace types, either before or after. Probably after, because constructors still sound more fun. So let's go do I want parser C again. We're going to want Sema C and yeah. And IRGen C. We'll need all three of these to get shit done. And we'll need a test. Test. New file. So let's just say ctors.laye. In ctors.laye, we're going to copy shit from here. And fuck it, we'll remove everything there. We want to return, for the time being, 0 until I know what I want to do. And what we want to do is... what do we want to construct? I could do my old-fashioned here too, but I think I want a more complicated structure so we could eventually test nested constructors. Nested constructors. Ooh, I hadn't even considered nested constructors. IRGen shouldn't be complicated because we're just going to calculate the field offset, basically, do the lookup, and then it gets transformed into regular assignments, basically. Unless we do optimizations on things and we're like, oh, the constructor initialized something to like a pattern of bits and we can do a integer assign. We'll figure it out later. So I don't think it's significantly, if any, different to just immediately support nested constructors as well. So let's just define struct foo and struct bar. And for shits and giggles, to show off that we can do it, we're going to say bar here, bar b, and then we can have like an int a bar b I'm not going to do a float because I don't technically have float literals. It would just be an integer literal anyway. So I could do like a string C and bool B. And that gives me a handful of things to do. So then in bar, what do I want to put in bar? We don't really have containers of any kind right now. Like I couldn't do an array literal. That's a good point. I should probably do array literals. I guess I don't really want to reuse the syntax for it. That's a arrays. A good question. Now that I'm thinking out loud, what's the syntax for array literals? It could just be the array type plus thing, which gives us inference for that. And then the name equals syntax would be optional. So you could just pass in values. And if it, and then we have to do a touch more, just a touch more sema work to determine if everything matches. Because if we're doing names always, you can always do names out of order. But if you're, as soon as we start doing unnamed things, we have to start tracking what index we're at in the field lookup, which is only slightly more work, but still worth considering. Is there any reason for me to not change the syntax for arrays? Right, like if I said int3 equals 1, 2, 3. I don't think there's not. You could technically even do int slice, probably. Oh no. Okay, there we go. I said oh no because I don't have a caps lock key. So anytime I type in caps lock, that means something done fucked up. Okay, but then I can do int slice rather. And int slice would make sense for constant arrays because they're going to live in program memory probably. But if this has to be stack allocated, I guess that's also fine. Right, like if this was ABC, where we can't put it in data, it's going to have to stack allocate the slice, which we'll get to. We might have to get to the semantics of initializing a slice later. So. Will be a fuck ton more question marks for that. The fun case is something like foo3x equals, yeah, assuming you can initialize foo from 2 ints. Correct. Again, that sounds like we're going to get it for free, but I don't know. To think about it, because each constructor would just become, okay, we've got a struct temporary now, which is fine. That's already what we're going to be doing with constructors anyway, is generate a temporary in the IR, initialize it, and then store it to the address that we're assigning to. So it's more a question of can sema infer the type than if we can generate the IR for it. Which I think it can, so long as the type on the left-hand side is known, then anytime we go into a constructor, we can infer the type of whatever field index we're at, or like named field we're at, pretty easily by just doing the lookup. Sorry, I don't mean to distract you, but is this video part of any of the playlists in your YouTube channel? I'd love to see the entire process to this point. Technically, I haven't done the entire process, and I don't think I've kept up with the playlists like I should. You're looking for the Laye programming language, Laye, which, I mean, we can go take a look. Let me pull up my channel here in like a new tab or something. View your channel in a new tab and pop it out here into a new window, hopefully. Come on, there we go. So playlists. The Laye, I think I've renamed it to the Laye journey and started re-uploading new things here. I've unlisted a few that are going to be incomplete. The videos are still around. I just don't want people finding the playlists to a dead series. Feel free to make your own. The videos are still there. So Hibiku is another one that I need to get back into. That's another compiler. The Laye journey will have more in it. I think I have to add... most of them are going to be live, that's why. So I need... this one needs to go in there. Probably the ABI compatibility one, but maybe not. Yeah, there's a few more. Just go check the video history. I did start a version of this compiler that got 7 episodes in. I guess 8 episodes in. Then this got pivoted to some other project, and that other project got repivoted back to a new version of this compiler, and that's been chronicled through some archived live streams. It's not organized well. That's my bad. You can... compiler refactoring probably did it. I'll get the playlists updated. That's a good shout. Let me where do I put? I don't have a notification. Let me add it to my phone. In 3 hours I'll update the playlists. How about that? Alarm. It is currently 1900. 7 o'clock. We'll go 10 p.m. Update playlists. Beautiful. Beautiful, beautiful, beautiful. Now, let me go back to chat. It's okay. I'll try to piece it together. Yeah, as soon as I started streaming things, I haven't been putting it back into playlists like I should have done. Like, there's another one for doing imports. This was a 2-episode thing for adding better import support to the language. You can see where I started doing Hibiku here. That got put on stream. The compiler in C did it. We did an IR for Laye way back when. Most of the streams have been Laye. Some of them have been Hibiku. Almost 2 weeks ago, I started adding 3D to OS. That'll get done more in the future as well. I've just got so many other things I'm doing right now. I started a Porth compiler. If you've seen Soding's stuff, I started working on a compiler for Porth. There's lots of good stuff. You'll find stuff to do. Anyway, so then yeah, what if we said fucking vec2 3 as is a thing. That just gets 2 question marks, because then I can say 1, 2, 3, 4, 5, 6. Comment. Just get some cases in there for my brain. I think that makes plenty of sense, though. I don't want to introduce a whole new syntax. Like, C# is getting these. Finally, honestly, it needed them. But I don't want to fall into the trap of needing a separate initializer sequence, whatever, for containers, for literally anything. Everything should be probably constructible with the exact same syntax. Hello, how's it going? Hi, Connor. Pretty good. I'm going crazy thinking about all the possible combinations of kinds of constructor syntax, but I think it'll be okay. We're about to try to implement constructors for my own programming language. So let's think what we want to do first. I'm kind of handling the complicated case first, which is probably not ideal. So let me make bar easy then, and we can say bar has int a and string b to cover 2 of my cases. So we can start with just bar. And we can just say like C0 equals something. Now I want to say bar in the first case, so I don't have to worry about type inference right away. And we can just make that 1 and hello bar. Right? That's one valid constructor. It has the type, it has the body. So then let's say bar C2, we want to have inference for. So then this one can be 2 and hello word constructor, right? Just something. And third, we want names. So let's bring bar back and say, let's do this in the other order. So then b equals this, and a equals 3. And this can be fields. I think these are our 3 easiest cases that we should try to handle in the parser. If we handle these in the parser, then the recursive version should just exist for free, I think. I say that. I say it'll exist for free. I think doing this is going to be a problem for container types. Because it's easy enough for me to say, hey, I see an identifier. That's the type. Let's look at this. It's more difficult for me to say, again, we're not there yet, but if I had int3 foo, I know we have a foo elsewhere, forget about it. I can infer the type just fine, right? I've got 1, 2, 3. But if I want to put the type before here, it's in an expression context. So it's not going to know that this is a type. We're parsing an expression. So I'm going to get int. Let's say it's not int, let's say it's bar. That's an array of bar, because bar is an identifier. An identifier is an expression. It's going to then see this and say, oh, we're indexing the value called bar. And this will be a lookup expression. But then there's not going to be anything there. So I could say 3. Okay, bar sub 3, what is bar sub 3? Like times something, equals something? Who knows? Well, not equals, because we're in an expression, not a statement. But, you know, could be an operator. It could be doing something. No, it's going to see this. And then we're going to probably have to rewind all the way back. So that's... Let me go add that to our list of issues as an even bigger what the fuck are we going to do about that? Time to problem solve. I bring this up because Laye already does... The Discord link does not work. Why doesn't the Discord link work? Discord. Invite people. Copy. That links to a friend. I need to edit the invite link to no limit and never, which should just exist. Edit. Discord, that's a new link, so save. And I'll put it in the chat just in case. Give that a shot. Very strange that it did not work. I set the last one to never expire. Maybe it just... Yeah, no problem. Maybe it just broke. Maybe it just broke. Woo! Well, if it worked, then we gotta go... Where are you at? Where's Connor? Nobody in the welcome channel. Did I break it? Is there no welcome channel any? Oh, you're probably maybe still doing onboarding? I don't fucking know. I don't know what's going on. Okay, so this case is going to be a pain in my goddamn ass. I can tell you right now. Right, so what I was saying is, since I've opted for C-style declarations here, like a fucking idiot who doesn't have any self-respect, we have speculative parsing. Basically, we parse and we figure out if something is or is not a type, and if it's not, we go back and reparse it as an expression or a statement. We're gonna have to do that to the fucking extreme for constructors. I thought these were gonna be much easier than they actually are. So what I might do, rather than trying to parse an expression and then backtrack and reparse a type, I'll do what I'm doing here and try to parse a type as an expression. And only if it is a type and there's a constructor opening bracket thing, we continue. Otherwise, we rewind, unparse the type, reparse the expression. But also only if it could possibly start a type. I'm not going to try to parse a type if there's no goddamn type there. So then I'll have to have, okay, if it's an identifier or a keyword or something, maybe I do just parse the type. It's going to be a nightmare. So this is not a case I care about right away. This would end up not what you understand anyway. So, any good podcasts? What kind of podcast? I have a few good ones. I like Ars Paradoxica. That's Ars Paradoxica, I think is how they spell it. Dungeons and Daddies. Dungeons and Daddies just concluded its second season, like within the past month, I think. And I don't listen to a lot of podcasts, and these aren't like people chatting podcasts. One of them's a fucking Dungeons and Dragons playthrough. The other is basically an audiobook. What else do I like? if you like the Dungeons and Dragons style stuff, I also am slowly getting through Girls Who Don't D&D. Avatar Braving the Elements, if you like Avatar, The Last Airbender. I'll post both of those. Girls Who Don't D&D. Something to fall asleep to? Do you want like sleep hypnosis? Or do you want like just actual stuff you don't have to listen to? Because I also have sleep hypnosis podcasts. Not that I'm trying to be hypnotized, but somebody's droning voice in my ears does help. Because all the ones that I'm listing off, I would rather you listen to. I listen to them for the content, not for the background noise. Let me open Spotify up on my other... I'm gonna open here. Well, then we'll look at it here. You're not going to get anything out of this. Kingdom Dad Monster. Ooh, they finally uploaded it. I'm going to have to listen to that. Okay. I use Steve Rose Hypnotherapy something as my current go-to. You can go listen to that one. I also like sometimes... am I at home or in my library? I'm in my library? Yeah, go home. I'm in my library. No, just stuff I don't have to care about, like not something with tension build up. I mean, yeah, then I don't care about these either. Steve Rose, I like his voice. There's Ars Paradoxica, it's very good. I don't know how to use the desktop client. I don't want to search either. Podcasts is going to show me all the guided sleep meditation and sleep hypnosis by Christopher Fitton. I like that one. There's Braving the Elements. I don't know. I don't listen to a whole lot of podcasts. That's about literally every podcast I've ever listened to. Those are my recommendations. These are fine. These are fine. Okay, so if I'm here, hear me out. If we don't R directive it just yet, we can worry about just parsing it. This will get picked up by fcheck, and it will run nothing, so it won't fail the fcheck tests just yet. We'll have to enable those later. We're going to start just parsing shit. Peace Codo? Oh my god, does that mean that my internet crashed, or is that... There you are, okay. Did I drop? 0 dropped frames, okay. Fuck if I know then. Okay. So if that's the case, if we're trying to parse things, then it's probably better that I try to parse... I don't know if I parse arrays, dude. I think I parse arrays? I don't know what's in my own parser. Parse type impl? Try parse type impl. We've got an identifier for those types. We've got a void. There's probably a... I think we parse type continue. Modifiable modifiers. Continue. So arrays would be in here. If it's a star or a close, then it's either a buffer or a slice. We've got buffer, we've got slice. Otherwise, it has lengths. Okay, so we do parse an array type in here somewhere. There's type array, so that's good. Just a star means it's a pointer. This means it's a reference. That's all we're doing. We don't do functions yet. We need to do functions sometime soon. That's probably going to make my life a living hell. Okay. And since it's a try parse, we can always rewind it. Okay. So let me go back to parse primary expression bonk. We are going to have to do a thing. For the time being, we are going to parse a type. So let's say try parse type. Continue and impl. Maybe parse. Let me just say parse type. What are my options for parse type? Parse type or error can parse type. So it looks like parse type. Well, that's going to say allow functions and allocate. I guess we want to allocate. It's all going to be in the result. I'm trying to remember my API here. It's been so long since I've modified the parser. I think what we're doing is we want to parse type from P. We want to say Laye parse result. type parse result. I'm going to call it something nice and verbose so I know what I'm dealing with here. So from the parse result, we then want to check if it succeeded. If type parse result success and parser at. If the parser is at the open bracket, then we're going to assume we're in a constructor. And since we're in a constructor, I'm going to do a thing. And we're going to put it up here. We're going to say static Laye parse result. By the way, the parse result is like a monad for storing parse information. It's going to have the node in question, along with any diagnostics generated for the node, and a flag saying if it succeeded or not. And I can combine those, and it manages all of my state for like my lists of diagnostics and shit automatically. If ever I destroy parse result, I get to choose whether or not the diagnostics survive and get printed or are killed before they make it to the user to determine whether or not something actually succeeded and stuff. It's a fun thing. You'll see a little bit of it here. Laye parse. We want constructor after type. Laye parser p. A Laye node. Just straight up take the type. Right? So I can just say here's a thing. I guess if it's inferred, this will be null. So I don't want to assert that it's not null. So parse constructor after type. So I could instead say parse constructor. Oh, don't want that either. Parse constructor body. How about that? So then we can have the type node. Then here we can assert p is not equal to null. Type node can be null. Then we're going to assert the token kind is equal to, in all cases, it must be this. And then I want my own parse result. Laye parse result, which will be true by default. Return results. But if it's true, it has to have a thing in it. So success is true. Then we need a Laye node. Fans back on for CTOR node. I'll just call it CTOR. It's node create in P module. The node kind will be node CTOR, which I do have, that's good. The node location. Ooh. What do I want the location of the constructor to be? I think for the time being, we just sit it at P token location, and we can update that later. We'll figure out what is the constructor's location. Should the caller be responsible for populating it? I ask this because we're going to reuse this for heap allocation as well. So I could just set it to the bounds of the open and close parenthesis, or like braces by default, which I probably will do. But the callers may expand the range of the location information to include the new keyword and or the type node. I think that makes enough sense at least. So then I can say dot node is CTOR. And at the very end here, just in case, result.node is CTOR. Because I might be changing that result, I want to make sure it's always going to return the constructor. Okay. So that's a thing I can do. Before we implement this, let's finish what we were doing down here. If we have a type, and we're at this, we then want to type parse result. No, we don't want to do that. We actually just want to say return parse constructor. We're going to say in the parser type parse result. If it's a success, I'm going to also assert that type parse result diags is null. So then otherwise, I want to result destroy parse result, and we're going to rewind. So I need to parser set to mark the mark. So then I'm going to say struct parser mark. Mark is parser mark. P. Then we try to parse a type. If we succeed, we continue. Otherwise, we reset to the mark and destroy whatever we were working with. And that should just free the diagnostics. That's all it's responsible for. It doesn't print them, doesn't do anything. So no matter what we do here, we're not parsing diagnostics. It's just not going to happen. I don't have a sophisticated enough parser to detect if it should have been a constructor after the fact. So if somebody says, like, that's not what I wanted to do. I wanted to come over here. If somebody says, like, or like this, then I don't have the capability to say, oh, did you mean that, like, float? Float doesn't exist, but, you know, like, I don't have that capability yet, and I might never. Okay. So this should speculatively parse a type. If it succeeds, it will parse a constructor. If it does not, it will backtrack and continue parsing an expression. So next, before I go too terribly much farther, this needs a type. And the type will be type node or infer. So if type node is equal to null, then node create the module type infer type var. Type var exists. Location would be the token location, and the type would be the context Laye types type. And that would be type node equals, and then I can assert type node and we get the null, and that's free inference. So we would always return something with a type, even if it's being inferred. And this needs to be ltie, which is a macro that puts it in a qualified type instead of the unqualified version. So then we now have type node. See, the type node needs to also be a qualified type. That's fine. Ltie this. We're not expecting a qualified type in as the constructor body. The qualified typeness. How do we show what that does? Type qualify is going to wrap it in a Laye type, which has its mutability in it. And actually, now that I think about it, when I say parse result, parse type, this returns not what I think it does. Because it's going to say result type. So we are actually getting a qualified type back, and I'm just wrong. So when we parse a constructor body, we need to parse a qualified type and let Sema tell people that it's wrong. So what I'm referring to is we don't want to say bar mute. We don't want a qualified bar with the mutability qualifier in a constructor. We just don't care about whether or not something's mutable in constructors. So I think for sanity, I'm going to allow it in the parser because I already have a type parser that qualifies types. I don't have something that can parse an unqualified type right now, which I might do in the future. If I do that, then we'll change this code. But for right now, I think we have to accept qualified types and check in the parser in Sema. At the very least, we can check at the high level here. If I do this bar mute 3, that makes a handful of hairs more sense. But I still don't think it is necessarily... Okay, new thing. var. This might be the only reason it's useful to have, oh boy, a qualified type in the constructor. Right? Like, the constructor shouldn't care, but the type inference system might. Just for the left-hand side here. So I don't even think we're going to complain in Sema for now. We'll backpedal if we need to. That's the wrong repository. I want to be here. So, fuck it. Let's, for shits and giggles, make this one mutable. And I don't think I have left-hand side inference properly working. I'll have to check that at some point. So let's go into issues and ensure var inference is working. Is inference just one R? I think it is, yeah. That's just my to-do list of things. My things to-do list. So in the parser, this takes in a Laye type. It's not a type node. So then if type node dot, if type dot node rather, node is equal to null, then type will be multi of infer, like this. Then insert the type node is not null, and then we don't qualify the type. So then in here, this is not dot node, it is dot type. The one problem I have with my type result thing here is it's a union internally, because I could parse a qualified type or a node, and that's a problem. Now, this also notes that these should never be null. Whichever one is correct should always be populated, which of course means that our checkup here isn't checking for a type that wasn't parsed correctly. It's checking if no type was provided at all, which is exactly what we want. Okay, so what I want to do now, why are you still in error? Why a node isn't compatible? It's not type. I want to go run the tests. This should not ruin any of the tests. It makes the compiler a touch slower, and then this fails because we're not actually parsing, but that's fine. Every other test passed, which is good. So then we're seeing all the cascading errors here. I don't have good error resolution for some of these things. That's not great. We need to get to parsing. So at this point, we've done that. We know we're at this token. We've used the token's location for as long as we know we're going to need it. So next token. We are now parsing a constructor. So we want to keep going until we hit a close bracket or the end of file. My roommate is cooking and it smells very good. He might knock on my door and ask me to taste. Speaking of, it has been an hour and a half since I've drank anything, probably. Hydrate, everybody. I should be doing a fucking... I need to set a timer. Hydrate every 30 minutes or something. Water. Oh boy, I love water. Beautiful. Okay. So we need to then expect at the very end of this the close. No fancy logic, just it needs to be there. So then we're gonna do while. We don't need to do while, we just want a regular while. While not parser at 2, I think will work. The close or token EOF, which should be a token. Do I have a parser EOF? I do, and it's checking for at EOF. Okay, so that works. While we're not here, we're going to do a thing. Step 1, if parser at the token ident and parser peak key equals, and let me double check that I'm using peak at ensure peak token. Okay, perfect. So if this, then we want to parse it as a constructor with a field name. Otherwise, we just, or not a constructor, a field initialization with a name. Otherwise, we don't want to put the name in there. So what I think I'll do, and I'm not actually sure, I think we want to have, like, up here, we have a constructor field struct that we just iterate, you know, populate one at a time, whatever the fuck. And it can optionally have a name. If it doesn't have a name, then it isn't the equal form. So we really want like Laye node constructor. Do we have like a CTOR? Laye CTOR. I don't. No. Okay, so I don't have any concept yet. So let's say Laye node CTOR init or constructor value field assignment argument. I don't know. What naming things is the hardest problem in computer science. Naming things. Laye node constructor fucking init field init. All right, let me just call it that for now, and we'll call it field init. 0 initialize it for now. Do a check. So then back in Laye.h, we need to go to meta type, lots of types, literals. Do I have one for, yeah, constructed. So I have Laye node initializers. Oh, that's probably a good point, actually. I probably don't need whatever the hell I've done. So Laye node initializer could actually be node create, key module, kind node CTOR node init member initializer. Is that what I'm thinking? That might be it. I might already have a member initializer. Member initializer. Aha, and then there it is. So an array index member initializer. Ooh, that's a good point. That's a good to do. Add that to the list of things I need to do. Just fucking this is that. These are very good comments, I know. Shit. So I think we can do that pretty quick though. We can say bool is named or is explicit. There's 3 cases here actually. Shit. Okay, we want Laye member init kind, and then I want a union of my bad decisions. Laye node index. So instead of field name, I can just call it name. Name or index, and then value. But then member init kind can be typedef enum this Laye member init none named index, right? Those are the 3 that we want. So then in the parser, we have the initializer, we have a location is p token location, and we have a type. The type, we have no idea what the type is. So That's, what do I use when I don't know the type? I don't remember what I do when I don't know the type. What do I do when I don't know the type? God, I haven't worked on this code base in so long. Parse primary expression. Like, we don't know the type of, for example, this. But we get it from the inside. The inside knows it. This doesn't know what the fuck its type is. What does the compound expression say about its type? Compound expressions, we give it a void type. Oh. That's kind of a special case. That's kind of a special case. These get its type from their results. Whereas if is also probably void. These get it from unknown. Oh, there we go. That's what I want. We want to get it from unknown. Here, else unknown. Perfect. So now we have an initializer. So then we want to ctor something else I haven't thought of, or I have thought of before, but not now, is so constructor needs a list of initializers. This is stored in the expression type field. This is not the case for the new expression, since it returns a point. Okay, so we're going to have to store all of these before calling constructor. Copy this field to here and rename it, which is not terrible. I think we'll be fine. What is the error at the bottom of this file? Too many errors? Wrong thing? I don't know. If I close it, does it go away? It does. Of course it does. Parser, so constructor, ctor dot initializers. We want to lcada push the initializer. Like that. Perfect. So now we need, I think I'm going to go after we finish the simple case for parsing. I'm actually starting to lose a lot of my focus, which is not great. So the initializer here, we want to say, if we're at an identifier, then we want initializer dot number initializer dot kind equals number init named, and then name. Name we said was a token, so that's equal to p token. Then advance the next token twice, right? So that gives us that. Then we want to say, where's this, man? It's right there. So then we want to say initializer dot member init value is parse expression. Straight up parse expression. So let's go look at the simple cases here. We're looking at all three of these, technically, if I can get them past the parser. Let me go remember how to do this. If I nod and out Laye, we want to do, I think, I don't remember any of my flags. Let me go look at the compiler. So I want, let's see, that's different. Backend, bytecode, emit C, emit whatever, we don't care. F syntax only. So I want E, I think, or just F syntax only. But F syntax only is going to give me sema. So I actually want AST. Okay, so if I do this AST, and then do Laye ctors, still parse errors. Invalid token kind everywhere, yeah, sure. So it started parsing up through compound. It has the first constructor. Oh, it did that. We did that. We got bar. The second one failed after the literal integer because we didn't get a comma. We didn't parse the comma. First off, why are you mad? Oh. Then what did we even get? How did it even parse the constructor if it didn't recompile? What the hell? Oh, let's use, okay, first off, that's using expect second. And it should be parser expect. This, we need to now do, what the hell do we do with this? Parse expression. Now you get results. Value results. Then we want to say that the value is value results dot node, which we can search is not null. And we can also result diags for value result, if not value results dot success at least. I don't think it'll matter, but do that. Context needs to be key context value result. Hey, what about that? What happens if I do that? Okay, we didn't do the comma yet, but it's a little bit happier. Slightly. No, it's not. So we're still missing something. Parser expect token kind into a result. Yep. Okay, so before I go run it again, we now need to say, if not parser consume, comma, p, comma, null, then break. If it does consume a comma, that's fine. It'll either hit this or it'll get another initializer. But I think that's the way we do it. I always do it differently for some reason, and it's not a good idea. Okay. Assertion result is not equal to null in parser expect. Parser expect needs something? Really? Why did I do that? Oh, it's the result. Oh, it's not the token. Oh, fuck. That's going to go in actual results here. Good job, me. Very good. Okay, still invalid. But it did recompile. So this one's fine. Invalid Laye token kind. Wait, is it? Oh, because we didn't do the infer either. So then in primary expression, right, we replaced this with do, but now I need a case for just this, which is going to do this with the var type, which I can pull out of here, which is null. So I just need the type node to be null. And if the type node is null, then we want Laye type 0. Right? There's nothing in here that I care about. Laye type not modifiable, no source node, no node. It's gonna overwrite it. Right. How we doing? The constructors, we're not printing what's in the constructors yet, but we have 3 constructors. So if I test, right, we're not running any execution for the constructors. CTORs, unable to resolve identifier string in this context. You know why? Strings don't exist. This is a U8 buffer. I don't have a string type yet. It's not a U8 buffer, it's probably an I8 buffer. Right? Should tell us like can't convert or something. Assertion false and unreachable. Uh-oh. On node kind CTOR. Oh, because it's trying to do sema on the CTORs now. Okay, well it parsed, it just can't sema. Which is fair, But hey, other than it not doing sema, which it shouldn't be doing, because, oh no, it should be doing, yep, because it's in the tests. You have to do some on the tests. Okay, well, that means we've parsed the simple case. We haven't done sema on the simple case. I'm a touch tired and loopy and don't want to finish this right now. I'll probably do more of this over the weekend. Hopefully, maybe we'll see. I don't know. But I got started, so that's good. You can check out the Discord. I post so many updates. Hey, look, somebody talked about compiler book. Any advice for writing a compiler? Should I do a bytecode compiler? I'll answer that later. Lots of places to talk people here. I'll post announcements when I'm going live or upload videos. I talk a lot of development here for compiler stuff, so does everybody else. So if you want to keep up with what I do off stream or off video, go check that out. I'm going to go fucking relax my voice because I'm starting to hurt to talk, actually. Have a good day, everybody. Thanks for stopping by.